this video, I'm going to go over how to use the limit comparison test to determine whether a series converges or diverges. So the first thing, and frankly, the toughest thing to do is to determine what to compare the series to. So let's call this A sub k here. I want to find some other series B sub k that's either convergent or divergent. And in order to construct B sub k, I suggest taking, especially when you have, quotient of polynomials the way we do here, or even a quotient of polynomials and radical functions, just taking whatever is the leading coefficient on the numerator and the denominator. So that's here. And I should call these subscript n, not k, since we're working with n's. There we are. So the numerator is going to be n, and the denominator here, let's have that be n to the fourth. Well, that's equal to 1 over n cubed. And we all know by now that this series is a convergent p series, since p here is 3, which is greater than 1. Okay, so now I know my series to compare this to, so I need to set up this limit. So there it is. There is my limit. And let me simplify this a bit, that is, rewrite it algebraically. It would be in your best interest to pause the video and try it yourself now. Okay, so how can I rewrite this limit? Well, in my numerator and my denominator, I can go ahead and try to factor something out. I'm going to factor out an n to the fourth. So n to the fourth, that leaves me with 1 minus 1 over n. And I'll do that to the denominator as well. So I'm going to factor out an n to the fourth from this, which leaves me with a 1 here plus 1 over n. Clearly, this divided by itself is 1. And what are we left with? Well, as n approaches infinity, 1 over n gets closer and closer to 0. So these vanish, these terms, leaving us with just 1 over 1. So what does this tell me? Both of these behave in a similar manner, so both converge or diverge. Clearly, then, this series will converge since this is a convergent p series. Okay, let's recap our conclusion here. Since this series here, 1 over n cubed from 1 to infinity, is a convergent p series, and this is important here, since the limit of this quotient of series, that is n minus 1 divided by n to the fourth plus n, over 1 over n cubed, since this limit is equal to 1, it follows by the limit comparison test that this original series must also converge.